Hello everyone, welcome to this lecture. This is our first lecture on Solidity programming. In this lecture, we will try to understand what is Solidity programming and why is it the most popular programming language for blockchain developers. In the upcoming lectures, we will be going through a deep dive of Solidity programming, and the upcoming series is designed in such a way that anyone who follows this series will be able to master all the concepts in Solidity. So let's get started. Now, before going ahead, let us talk about the agenda for this lecture. In this lecture, we'll be talking about what are programming languages in general. Then we'll be understanding what is pseudocode, how to write computer programming logic, and finally, we'll be talking about Solidity in general and what are smart contracts. So, nearly everyone has used computers at some point of time in their lives. You may have used a computer to play some video games, to buy something online from some website like Amazon, to listen to some music like Spotify streaming service, or to interact with your friends using some social network sites like Facebook or Instagram. Apart from that, computers are also used to forecast things like weather. Computers are used to build aircrafts. They are used to generate exciting movies. They are used by companies for administration. And also, computers can be used for amazing things like having financial transaction audits. So, what is a computer? Let us try to define that first of all. So, first of all, a computer is a machine that stores information, and a computer also manipulates information. So, information storing and information manipulation are the two main tasks that any computer does. And it does so, both of these tasks, using some kind of program. So, to summarize the task of a computer, you can say that it is used to store information and manipulate that same information using something called as a program. At this point of time, we don't know what is a program, but we will try to gradually understand what is a program. So, this definition has two main components. The first is that computers are information processing machines. So, you can say that computers are information processing machines. Now, this implies that we may put some data inside a computer and then have its output shown to us for us to comprehend. So, information processing machines is what a computer actually is. Now, computers aren't the only devices which can manipulate and process data, right? After all, when you use a calculator, it also has some kind of input. It can do some calculation like addition, subtraction, multiplication, division, and it will give you some output on the calculator screen. Apart from that, a petrol pump is also a device which can manipulate and process data. In the petrol pump example, we can have two inputs. The first one is the rate of petrol, and the second one is the rate of flow of petrol. So how will your petrol pump calculate how much money you have to pay to the petrol company? Basically, it will multiply the rate of the petrol. Let's say the current rate of petrol is 100 rupees in India, and it will multiply that with the rate of flow of petrol per unit time. So usually there is an IoT device which will track what is the flow of the liquid petrol, and basically that is how multiplying these two things will give you the total money that you have to pay at the petrol pump. So these devices, although they do process and manipulate data, they can't be called as full-fledged computers, right? Because after all, they are working on a single task. They are not able to perform a wide variety of tasks using different kinds of programs. So what exactly is a computer and how is it different from these kinds of devices? So earlier I had mentioned something called as a program. So what is a program? So computer program is a collection of instructions that tells a computer exactly which steps to perform and in what manner. So after all, a program is a software, first of all, which contains instructions to guide a computer to execute steps. Now, because of these kinds of softwares called as programs, a computer will behave like a word processor at some point of time. It could behave like a video editing machine at some other point of time. It could behave like a game at some other point of time. So I think you are able to see the pattern. Depending on what kind of software or what kind of program is working at the current time, a computer can behave in a different kinds of ways. So that is what you can say is a computer. It is a machine which can read and understand different programs to give us different kinds of tasks and different kinds of functionalities depending on whichever program is running at the current time. And whenever a different job or a different program is running, you can expect different kind of output from a particular computer. So to understand this concept in a better way, let us try to assume that a computer is an electronic device which gets some kind of input from softwares called as programs. And depending on whatever is written in these programs, it will follow out some instructions. And the program will also tell in which order to execute what kind of instructions. So a computer can be thought of as a universal machine. Now, depending on whatever program or software you're feeding to a computer, it can carry out almost any task that you can think of. So a computer is an amazing electronic device which can carry out whatever tasks you mention to it. And a program or a programming language is nothing but a particular language that you can learn to speak or communicate with the computers. Now let's talk about pseudocode. The word pseudocode is divided into two steps. First is pseudo and second is code. Pseudo means something that is fake, and code basically means any kind of application or software. So pseudocode, although it resembles or it helps us in understanding what a program is, it does not actually look like a specific computer program. It is in fact an informal way of describing how a particular computer program should behave. To understand pseudocode in a better way, let's try to take some example. Let us write the pseudocode to understand the daily routine of someone living near the mountains. So if someone is living near the mountains, there is a probability that it could be snowing some point of times. So how could a daily routine of a person be designed? Let's try to implement that using some pseudocode. So first of all, the person will be waking up. So wake up, that will be the first step, definitely. Next thing is the person will check if it is snowing or not. So if it is snowing, then the person can check if the roads are closed or not. So within the snowing condition, we can have one more condition, which is if the roads are closed, then just go back to sleep. All right. So that will be how our if snowing condition can be broken down into multiple steps. So pseudocode, as you can see, can be a representation of a programming language and some code, but not actual code. We are trying to write things up and break it down in the form of logic, which is very informal, or you can say in plain simple English. So continuing with this example, if the roads are not closed, so the second condition that we can have on a snowy day is that the roads are not closed. Then the person can get dressed and he can clean his driveway. And if this condition of snowing is not true, or you can say point number 3, if it is not snowing, then the person can again get dressed, followed by have some breakfast, and he can finally go to work. Now, this is a very simple representation which can outline the routine of someone living near the mountain region. Now, as you can see, this is a pseudocode implementation, and What it consists of is nothing but a set of instructions or a set of steps which are followed in a particular order. So a program is nothing but representation of pseudocode in a way that computers can understand. So for someone who has just started his first programming language or is new to the world of software engineering in general, what I would personally recommend is start practicing writing some pseudocodes in order to get familiar with building your computer logic. So pseudocodes, it is nothing but a particular tool that you can use just to improve your programming logic. And that is how most of the computer developers start their journey of writing software. So we have seen some of the basics of programming language and programming logic. Now there are a huge number of programming languages which can be used to build amazing applications for softwares which can interact with the computer. Some of the famous programming languages are C, then we have C++, we also have dynamic languages like Python, JavaScript, we also have the Java programming language. Huge number of programming languages are used day to day in order to achieve different kinds of tasks and build different kinds of softwares. The programming language that we will focus on as blockchain developers is Solidity programming language. Now, even though we can build blockchain applications in all these programming languages, why are we going ahead with the Solidity programming language? Let's try to understand in the next part of the video. Now, the Solidity programming language is a programming language which is used to create applications on the Ethereum blockchain. Now, we have already discussed about Ethereum blockchain in depth. Kindly see the complete lecture series on Ethereum blockchain before you start with the Solidity programming language. Because in order to write smart contracts or applications in Solidity programming, you need to understand what is Ethereum blockchain and how it actually works. So going back to the topic of smart contracts, let us try to have a recap of what are smart contracts. So as we have seen in our Ethereum blockchain series, a smart contract is a piece of software which is stored on the blockchain that automatically executes a certain kind of agreement. So you can say it is a executor of a particular agreement. Now let's take a very simple smart contract into consideration. So a smart contract, after all, is nothing but a piece of code which is deployed on the blockchain. And the smart contract will control the behavior of the different accounts on the blockchain. Now let us try to understand with this very simple example how a particular smart contract might look like. So let's say we have two parties involved. One is a vendor. Let's say he's a vegetable vendor. And on the other hand side, let's say we have a shopkeeper. Now, the shopkeeper will promise to pay the vendor for the vegetables as long as the temperature of the vegetables is less than 20 degrees Celsius. So if both these parties, the shopkeeper and the vendor, don't trust each other, they can have this agreement between them inside a smart contract, which will ensure that both the parties are working in the correct manner. So let's try to write down a simple logic for a smart contract, which will ensure both the parties are able to get what they want. So the condition that the shopkeeper has is that if the temperature of the vegetables is less than 20 degrees Celsius, then he will pay to the vendor. If the temperature of the vegetables is greater than 20 degrees Celsius, then the shopkeeper will not pay to the vendor. So maintaining the temperature of the vegetables below 20 degrees Celsius in our case is the job of the vendor. and paying the correct amount of money to the vendor on the delivery of the vegetables is the role of the shopkeeper. So, in our scenario, what we can do is we can build a smart contract where we can have an IoT device. Basically, we could have something like a temperature sensor which is connected to the truck of the delivery vendor, and the temperature sensor will continuously keep on monitoring what is the temperature inside the truck. Now, once the vendor reaches the shopkeeper will check the temperature. Meanwhile, we can have a smart contract containing a piece of code, basically a sort of instructions, in which the shopkeeper will temporarily store the money which he has to pay to the vendor. Now the smart contract will check the temperature, and depending on whether it is more than 20 degrees or less than 20 degrees, if it is more than 20 degrees, then definitely the money will be locked in the smart contract and it will be returned to the shopkeeper if the temperature is too high when the vendor had delivered the vegetables. And on the other hand side, if the temperature which is maintained inside the truck is less than 20 degrees Celsius, as told by the IoT device, then the money which is temporarily stored in the smart contract will be going to the vendor. Now, this is the kind of system where both the shopkeeper and vendor will be behaving in a way that they are supposed to. No one can cheat a smart contract. So, if anyone like the shopkeeper or the vendor behaving in a malicious way, then the smart contract can work and execute steps accordingly. So, we can have a smart contract which is basically a trustless code. So you don't have to trust anyone, not the counterparty, nor any trusted third party. You can just trust this code to execute whatever steps are required for various kinds of business agreements. What we witnessed just now is a very simple example of the kind of applications that can be built using the blockchain systems. Definitely, in real world scenario, we can have a lot more complex systems than the one we just mentioned. But this is just a simple example to get started as to what kind of applications you can build on blockchains, which are basically decentralized system with no kind of trusted third party. Now you might be thinking, why should I even write smart contracts for an application like this? I could use any other programming language like Python, Java, or C++ to design a software in this way. But understand the difference between smart contracts and any other application in some different programming languages. Smart contracts are code which are deployed on the blockchain. And if you remember one of the properties of blockchain, the data which is entered inside a blockchain, it is by default immutable. So because of this property of immutability, in our case, the shopkeeper and the vendor, neither parties can manipulate or modify the code in order to suit their needs. So since it is a decentralized application working on the blockchain, once it is deployed on the blockchain, no one can change the set of instructions which are run inside the smart contract. Apart from that, a smart contract is also automatically executable. So there is no need to press a button in order to execute certain steps of the smart contract. It will see the conditions, and if the conditions are met, it will automatically execute the next set of instructions without anyone's permissions. Apart from that, a smart contract is also deterministic. Now, what does deterministic mean? So, deterministic behavior says that when a particular set of conditions happen, only a particular set of output will be received. So, let's say we have a particular set of conditions. Whenever these conditions are met, the exact same output will be seen each and every time. It is not possible that your code will behave differently even if we have the same condition. That is what deterministic means. Exact same behavior is expected whenever a particular condition is met. And the last thing Also, one of the most important thing about the smart contract is that by default, this piece of code is unbreakable. So that means the code written inside the smart contract, which is deployed on the blockchain, it is tamper proof. So that's it about the main properties of smart contract. Now, why is Solidity the preferable language for writing the smart contracts? So Solidity as a programming language was designed specifically to write the smart contracts on the Ethereum blockchain. And Solidity was found in the year 2014 and it started working around the year 2015. And since it is a very old programming language, definitely it has the best user support and a lot of advanced features for interacting with the Ethereum blockchain. So in the year 2022, which is the year as of time of this video lecture recording, 95% of all the Ethereum blockchain applications are built using Solidity. Not only that, more than 80% of all blockchain applications are built on the Ethereum blockchain. So to be a good blockchain developer, it is a must to be very good at Solidity programming language.